We are back with another episode talking about an exponent rule. This is one of my all-time favorites. It's called the power to a power rule. And boy, oh boy, do you feel powerful when you know how to use it. So what is a power over another power? That basically means you're going to have two exponents, one on top of another. Okay, we show that outside of parentheses, and the rule you're going to have to follow is called the power to a power rule. This is a new rule of exponents, so make sure to pay attention, and you're going to get into some lengthy problems where you're going to need to know multiple rules. Okay, I'm going to go over the basics here with these three problems, and then we're going to use that knowledge, and hopefully you already have your knowledge of negative exponents and the product rule, and we can use that information to answer these two more challenging problems over here on the right side. So what is the power to power rule? Power to power rule means if you have one exponent and you're raising it to another exponent, you are just going to multiply your exponents. So a to the m power, all to the power of n, would be a to the m times n. You multiply these two values. So knowing that rule, we're going to use that exact example. And now we're going to say z to the fifth, all to the power of 3, which we need to multiply the 5 and the 3 together to get z to the 15th power. It's as simple as saying z to the 5 times 3, which then leads you to z to the 15th. Okay, don't overthink this. Just follow that rule when you see one exponent over the top of another exponent. Now here, what we have is two parts inside of the parentheses. So this is similar to the distributive property. We have this exponent on the outside of the parentheses, and we need to distribute that 6 to the b and to the a. It needs to go to both of them. So when you see that, you need to make sure that that 6 goes to the product, both parts, a and b. So this would turn into a to the 6th, b to the 6th. Okay, hopefully all of that makes sense to you. You understand the three different examples that were given, and now we're going to use these foundational skills to answer these questions over here. Remember, we already need to know what the product rule is. So if you haven't watched the video on the product rule, there may be some things that I do in here that might be confusing. If you also don't know what negative exponents do, you might also run into some issues in what I'm doing here. So make sure to check into those videos if you're not sure what the product or the negative exponent rules are. And let's get started. So the first thing I'm going to do, I don't want to do anything with negative exponents until the very end. We're going to wait to see if at the end result we have negatives. First thing I want to do is always take care of the power to power rule. Okay, so it should go in this order: power to power rule, product rule, negative exponents. So the first thing we're going to do is we're going to just take care of this part of the problem here. I'm going to distribute that 2 to the -1 and to the n. So what I'm going to get here is I'm going to just bring this stuff straight down. M to the -9th times m to the, I want to multiply -1 and 2 together and get a -2. N does not have an exponent above it. There's a 1 technically there, so you're saying 1 times 2, which you're just going to get n to the 2nd. And then n to the 8th gets brought straight down. So the only thing we really adjusted was this. Notice the only rule we used was the power to power rule. Now I have all of this written out, and I need to realize that I am going to be multiplying my bases that are the same. So here what I'm going to end up getting is m and m, bases are the same. I'm going to add -9 and -2 together, which that is the product rule. M to the, I would get -11 here. Now n squared times n to the 8th, I'm going to add those together, 2 plus 8, because my bases are the same, and I would get n to the 10th. So now what I have is this, and some students will stop here and they'll be like, sweet, I'm done. I've got my m by itself, I got my n by itself, but we have one issue. If you've watched that video on what we do with negative exponents, we know we're not allowed to have them. So I can't stop with a negative exponent for an m. I need to do something to that. And because it is a negative exponent, all I need to do is just bring that information to the bottom of a fraction. So I'm going to keep this up on top, n to the 10th, and I'm going to put it over m to the now positive 11th power. So Your final result is n to the 10th divided by m to the 11th, and you've just completed a more challenging problem using your foundational skills. Over here, look at this problem, and the first thing I want to focus on is I want to see, is there a power-to-power rule? If there is, that's the first thing that you should do. So in looking at this and viewing this problem, I would hope that you right now are focusing on this part right here and kind of ignoring the start to it. We're not going to do anything to the start. We want to take care of our power-to-power rule first. So I'm going to distribute that. Notice that I draw these lines just to help me remind me, because a lot of times I'll see students multiply this and they'll forget to put a 2 above that base 2. So I'm going to bring everything down exactly as I see it. 5x to the negative 5th power, y squared. I'm not going to worry about the fact that there's a negative exponent until the very end. Bring the 2 over here, so I'm going to say times 2 squared, and x to a negative times a positive equals a negative, and 14 times 2 is 28. So this is what I now have. Now looking at this, I'm going to change 2 squared just to a whole number. 2 squared is 4, x to the negative 28th. And they want me to multiply that by all of this. I'm just going to bring that down, doing little parts at a time. Now I can multiply 5 times 4. 5 times 4, piece of cake, we got 20. I have an x, a y, and an x. So nothing's going to change with my y, but I do need to use the product rule with my x's. Product rule says if my bases are the same, add my exponents. So I need to say negative 5 plus negative 28. Now adding a negative is no different than subtracting. So negative 5 plus negative 28 takes me all the way back to negative 32. And then y squared just stays y squared. I made a mistake there. That should be a 33. My apologies there. Negative 5 minus 28 is negative 33. Okay. Now, 20x to the negative 33rd and y squared. This is an issue. You need to notice that you have a negative exponent and ask yourself what to do with it. Again, no different than this problem where we had a negative exponent at the end. We brought it to the bottom of the fraction. I'm going to write 20 and y squared on top. But this information here, because it's a negative exponent, needs to drop down to the bottom, x to the 33rd. So your final result for this problem would be 20y squared divided by x to the 33rd power. Which rules did we use in solving this? We used our power rule first. We simplified 2 squared. Then we used our product rule because we had bases that were the same. Added these together to get negative 33 after making that quick mistake, and I fixed it. And then we took negative exponent rule and moved it to the bottom, the denominator of a fraction. Okay, so here is a problem where you're using 3 of your exponent rules. Here's a problem where we use power, we use product twice, and again, we used all 3. Power to power, product rule, and negative exponent rule. And here's our foundational power to power rule, just things that you need to know. Big takeaways: if it's outside of 2 terms, it needs to distribute. You multiply your exponents together. Different than the product rule where we add them together. Here, where we have one exponent over the top of another, just multiply those bad boys. All right, thank you for sticking around. Hopefully this all makes sense to you. Like always, leave me a comment if there's anything that you're confused by. I'll try and get back to you and help explain whatever it is that you're not sure of. And good luck on your upcoming